Hey everybody, finally getting around to a part 2 for my Ford-A-Hoe project. The first order of business is this swing cylinder here. I'm going to have this cylinder rebuilt, partly because I heard that the swing on this backhoe was bad. I don't know what was bad, but it was bad. And also this cylinder is going to be a real asshole to access once it's installed in the frame. But anyway, before I do that, before I sent it out to get it rebuilt, because I'm in no hurry to do that, I imagine another reason the swing was bad are these terrible teeth. Of course, the worst ones are in the middle, and the ones on either side are perfect. So I just started grinding these clean and smooth and getting all these raised edges off, getting it nice and flat, and these surfaces here I'm going to grind and clean up, get it nice and clean, and then I'm going to build these teeth up with weld. I'm not going to use any like fancy hard facing stuff or anything, because, well, firstly, I don't have any, it's expensive, and I'm not going to buy any, but more importantly, I'd much rather repair this gear again or buy a new one or something than have these teeth super hard and have it wreck the next gear, because that's a round gear, and this seems pretty easy to repair. So anyway, I'm just going to use regular, I'm probably going to use 6011, maybe 6013, because I'm not much of a fan of 6013, but it lays a really nice flat smooth bead, flux, or rather the slag chips off really easily, and I'm not really looking to weld two pieces together. I'm just welding a new surface on, and so it has the same tensile strength and everything as 6011, but it just doesn't penetrate as well. But we're really not looking for penetration. So that's that. So I'm going to grind these up and get them welded. Okay, so something to note when you're grinding these teeth off, if you happen to be doing something like this at home, since these gear teeth got smushed inward, that material had to go somewhere. The material doesn't just, disappear. So imagine if this was a piece of clay and you squish it, it's going to squish that way, which is why I ground this surface here to flatten it out. And it's also going to squish this way. So the tops of these teeth, of these middle teeth, are a little higher than the outside good teeth. So I don't know, let's see, I'm going to hold this straight edge on here. On one side I'm going to hold it right against the gear, or right against the last gear tooth. And you see it's pretty far away from the other tooth there, because it's touching, where is it touching? Right there, that tooth right in the middle at the number 6. Maybe the number 4, I don't know. A couple of them. So I'm just going to repeat this process of putting a straight edge on here, marking some teeth that are high, grinding those down so they're all along the same plane. And I'll use these two outer teeth, this one here and this one here, because they're in good shape as my datum point, if you will, to reference all these other teeth to make sure they're flat, both when I'm grinding and after I weld them and I'm grinding the weld away. Alright, got her all ground up. Now, some of my more observant viewers may notice that you can kind of see the line here, because I only ground away where the gear was damaged. The gear that engages in this only seemed to be engaging about halfway. As you see, even in the middle gears where it's in bad shape, the bottom part of the gear is really quite nice. So I do have some alignment issues, and that'll all be sorted out when I get this thing back on. And it definitely should last a lot longer with full gear engagement rather than partial engagement. Well, I just welded up the teeth. Here it is, all nice and ugly looking. I just used 6011, both 1/8 inch and 3/32. I used 1/8 inch for the larger gaps, and then when I wanted to deposit a lesser amount of metal, I used the 3/16 electrode. And of course, make sure to cover the rod so you don't get any weld spatter on there. Also, the oil that spills out of the cylinder that you soak up with a rag, move that rag before you start welding, because believe it or not, it will catch on fire. So I'm going to bring this up to the workbench and start grinding away. So I'm just doing the same thing as before. First I ground the tips of the teeth, ground them all flush. I had a, just like I showed you before, I just used a straight edge to make sure they're even. That was easy, and then I ground the teeth flush this way, because that was easy. And then the most difficult pain in the ass part of it is matching the profile. So I had the idea to make this little tooth gauge here out of a piece of aluminum sheet metal. I used a good tooth here, and you see it fits right in. But for example, over here, even though I ground it, it's still not quite right. I need to put more weld in there. Oh. See, because there's space. But if I move down to the bottom of the tooth, it's in good shape. So I'll be using this as a guide to grind to, and also to add more weld, or to determine where I need to add more weld. Alright, a couple back and forth between welding and grinding, and I think we're pretty much all done. There's a couple spots here and there that aren't quite perfect, but you got to come to a point where you have to ask yourself what's doing a good job and what's wasting your time. For example, there's a little chip out of the corner there that didn't get filled in with weld. That really doesn't matter. And see, I don't really like on this face of the tooth, there's a weld bead there and a weld bead there, but there's a little gap in between that isn't perfectly smooth. I mean, it matches up well with the tooth gauge, but you know, just little stuff like that isn't perfect. But I think this is fine. I went a little above and beyond with a couple of things here and there, because I said it's a lot easier to do it now when it's out and can be worked on as much as I want, rather than put it into the housing there and then find out something breaks later on, or it gets sloppy or whatever. Spend a couple extra minutes here. But anyway, that's it. That sums up this part of my series on the Ford-A-Hoe. I'm going to bring this to Dependable Hydraulics and get the cylinder rebuilt. And while that's happening, I'm going to do some work on the main frame here. I still have to get around to finding new bushings. These things are all sorts of clapped out and the wrong size and just beat to shit. So I got to call International, and hopefully they still make these. And then as for the rest of this, I'm going to clean it all up and degrease it. And I think there's no real repairs to make. Degrease it, paint it, and I really think that's about it as far as this goes. Oh, the other thing, you see these little pieces right there. I have to weld this back onto it, because that's where the valve bank mounts. That's not a big deal at all. So I'll get this all done. I'll get it painted, and Then I can start working on the mount that attaches onto there, that'll attach onto the tractor. I was at Logan Steel not too long ago, and I got all the material I need, so I'm going to start fabricating that soon enough. So stay tuned for the next episode. Leave me a comment if you would like, or a suggestion, and hit the subscribe button if you haven't already. Thanks for watching, and stay tuned for more.